Okay, we're going to look at temperature conversions, and we're going to look at measurements of density. And what I did before coming here was I took some water, and in the water I measured its temperature on two scales, a Celsius and a Fahrenheit scale. When the water was at the freezing point, the temperature was 0 and 32. When the water reached the boiling point, it was 102.12. Now I plotted this data on the plot. This is my ordinate, which is the y value, 0 and 32 and 212. This is my x value, 0 and 100. And I have an equation of a straight line, y equals mx plus b, where the slope is the rise over the run. Now, my y value here is Fahrenheit, so I can say that the temperature in Fahrenheit is equal to the slope, which would be 212 minus 32, 212 minus 32 is the change in y, the rise, divided by the run, the change in x, which is 100 minus 0, times the value of the x-axis, which is the temperature in Celsius, plus the y-intercept, the value of the y-axis, y value when x equals 0, which is 32. And this gives us the equation TF equals 180 over 100 TC plus 32, which can be rewritten as TF equals 9/5 TC plus 32, or TF equals 1.8 TC plus 32. Now I come over here and I have a very similar equation. This is the density of water, and when I had no water, the mass was 0, the volume was 0. When I had 10 mils of water, the volume was 10. And if I do the same equation, I can say now that y equals mx plus b. So the mass of is equal to the delta y over delta x times the volume plus b. And the mass is equal to 10 over 10, 10 minus 0 over 10 minus 0, v plus b. So the mass and the value of b, is 0. So I can now say that the mass of water is equal to 1 times the volume of water, and this 1 is the density of water, so the density of water is 1 gram per mil. Now in the real lab, you would measure this to the precision of your instrument. What I want to point to you here is that this equation here, when I have y equals mx plus 0, the slope becomes the ratio of the y value to the x value. So this equation, this equation here, that the mass is equal to the density times the volume, is much simpler than this equation here. And in the next video, we're going to look at how to simplify this equation by asking ourselves, at what value does the y-intercept equal 0? That is, when do the two scales converge? And we'll make that value equal to 0 in the next video. Thank you.